Hello everybody. So in this video, we're going to be looking at chapter 10.3 notes. If you would like to print those out before you watch this video, I would advise it. Otherwise, you might want to keep pausing and then jotting these notes in your math notebook. I would encourage you to have two different colored highlighters or markers as you go through and you take your notes today. So you could always pause for a quick minute while you grab your materials or your math notebook. And then let's get started. So today we're going to be talking about an inscribed angle and different theorems pertaining to those in a circle. So a central angle, remember, would be if here is your center, it's just the angle that the two radii form with the center. An inscribed angle is different from that. So I'm going to use my highlighter here. So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So it's on the circle and it contains two chords. So that's kind of not surprising. So anyway, I'm going to draw a ray from this point here and out that way. Okay, so the inscribed angle has the vertex on the circle. All right, so that's going to be my yellow highlighter. It might be a little tricky to see. The arc that lies in the interior of an inscribed angle and has its endpoints on the angle is called the intercepted arc of the angle. So this is the intercepted arc. So that's what they're looking at. Okay, and we're going to be looking at the degrees of both. If all the vertices of a polygon lie in a circle, the polygon is inscribed in the circle. Polygon is inscribed. So the polygon is inscribed in the circle, and the circle is circumscribed about the polygon. The circle is circumscribed about the polygon. So that's kind of what that's looking at there. All right, theorem 10.8, measure of an inscribed angle. So there is a very light A, B, C, and D here, but it's really hard to see. So I would advise that you just make those points bigger. Even if you are working in just a regular lined math notebook, I would absolutely write out this rule here because it's very, very important. There are really three really, really important rules that we're going to do today, and this is one of them. Okay, so the central angle equals the arc. So we talked about that in an earlier video. The measure of angle ADC equals the measure of the arc. So I'm going to just write review. The measure of angle ADC, so our central angle, equals the measure of arc AC. So this is central angle equals arc. Okay, but that is different for an inscribed angle. So if an angle is inscribed in a circle, then its measure is half the measure of the intercepted arc. So that's saying that the measure of angle ABC equals 1/2 the measure of the arc. And there's another way you could say it. I could say twice the inscribed angle equals the measure of the arc. Okay, so the measure of the inscribed angle, angle ABC, equals half the measure of arc AC. Another way of saying that, if I want to multiply each side of the equation by 2, 2 times the measure of the inscribed angle, angle ABC, equals the measure of the arc. So the inscribed angle equals half. Inscribed angle equals half the arc. Okay, so these examples are pretty quick to go through and do. So if you look at number 1 here, I have an inscribed angle that's 17 degrees. So I'm going to multiply that by 2, and the corresponding arc is 34 degrees. So here in number 2. So in number 1, I was given the inscribed angle. Okay, and I doubled it. In number 2, I'm giving the intercepted arc. So since I'm given the arc, I really want to divide it by 2. So I'm going to take the 138 and divide by 2. Or I could do 138 divided by 2. It doesn't matter. And I'm going to go ahead and do that on my calculator. And I'm going to take 138 divided by 2. I'm going to get 69. So the angle equals 69 degrees. So now I can say 3x equals 69 degrees. So if I divide by 3, I can get x, which is 23. Okay, and then in number 3, this is an important question because we're going to be doing a theorem pertaining to this one in just a short couple minutes. So this is a right angle. So if this is 90 degrees, I'm going to double it, and that means this is 180 degrees. So those right angles are actually pretty handy. And if you think about it, that means we're going to go here. And wow, if it's 180 degrees, that means that this would form a semicircle. And we're going to have a rule about that in just a minute. So 4x plus 8 equals 180. And now it's a two-stepper, so we're just going to subtract 8 to solve. I get 4x equals 172, divide by 4, and I'm going to get, I made a mistake. No, I didn't. That's 180. So I divide here, and I get 43, I think. I'm looking at my answer key, but I think I had done it a different way, and I get 43. All right, so those are kind of a couple quick, straightforward ways that we can do that. All right, I'm going to go on to the next page of my packet. And I said that there are 3 important rules that we're going to do today. This is a rule that I would say is not that important, but it's just something that they talk about in our unit. So this is theorem 10.9. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. All right, so all that's saying is here is inscribed angle A. I went ahead and made that A bigger. So here's angle A. And the arc pertaining to that, so here's my inscribed angle, angle A, angle DAC. The arc that goes with it is arc DC. Okay, and if you look, there's another inscribed angle that shares the same arc, and that's angle B. So when 2 angles share an arc, so if the arc is shared, angle A will be congruent to angle B. And the inscribed angles are congruent. I wouldn't say that that's the biggest deal in the world, but it's just something that they talk about. So if the arc is shared, such as arc DC, angle A is going to be congruent to angle B because the inscribed angles are going to be congruent. So that leads us to example A here. If angle CAD is a right angle, this is a right angle, which means this arc is going to be twice that, so it's going to be 180. And I could put a diameter in there if I wanted. Then to get the measure of angle CBD, you're going to take 180 and divide by 2, and you get 90 degrees. Okay, so the next couple examples are using that rule. Number 4, you have the first angle, angle X. Second angle is the 50 degrees. They are sharing the same arc, so X equals just 50 degrees. Okay, same thing here. This angle is 80, and then this arc would be 160. So the arc is 160. This would also be 80. So you would just write 3x plus 5 equals 80 and go ahead and solve that. And then here you would say the same thing, 5x minus 2 equals 4x plus 9. So if you'd like to pause the video, you may, and just get these answers really quick. The math's pretty easy. So I get 3x equals 75, divide by 3, and I'm getting x is 25 for number 5. And then here I would subtract the 4x first. X minus 2 equals 9. I'm going to add 2, and I'm going to get x equals 11. And remember, you can always go back and check your answers by plugging them in. So there was really no math to check in number 4. But in number 5, if I plug in the 25, 3 times 25 is like having 3 quarters or 75 cents. I add 5, I get 80 cents or 80 degrees in this case. And then here I plug in the 11, I get 55 minus 2 is 53 degrees. And then here, 44 plus 9 is also 53 degrees, so I'm good to go. All right, so that theorem, I would say, is not critical. It's not such an important theorem, although you still could see some of that next week. The next 2 theorems, I think, are really, really important. This is a lot of words for something that I've already talked to you about. So if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle, and that makes perfect sense, right? So if this is 90, that means that this is 180 because the inscribed angle is half of the arc. So this is 180, which means it's a semicircle, and now you have a right triangle. So conversely, if one side of the inscribed angle is the diameter of a circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. Okay, so this is an important theorem, but we've kind of reasoned our way through that already, so now we're just going to be using that in a few minutes. Theorem 1011. I have to tell you, I really love this theorem. So we're not even going to look at the words for a minute, and I just want to talk you through thinking about this. So let's say this angle here is 80 degrees. So we already discussed how the inscribed angle is half the arc. So if this is 80, from here to here is going to be double that, or 160. All right, back here, the 3 angles in the triangle add up to 180. All the way around the circle is 360. Same thing here. So this is 80. The arc is 160, which means the rest of the arc, so if I do the measure of arc ZXW, the major arc, I'm going to do 360 minus the 160. I actually think I just did that in another video. So if I do 360 minus 160, I get 200. So I am going to use my highlighter here. So the 160 is the minor arc for arc ZW. And then our major arc, which is 200, goes from here to here. Okay, so that pink arc is 200 degrees. Well, that's the arc. So now the corresponding inscribed angle is going to be half of that. So half of 200 is 100. Whoa, 80 plus 100 is supplementary. And that always happens, which makes perfect sense because if you have an inscribed quadrilateral, these 2 angles will always have to add up to 180, and that's just what that's saying, because the vertices here will together form the whole circle. So a quadrilateral, let me try again. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. And that's another really useful theorem to use. So I'm going to flip over to page 3. And let's just try to do some of these examples here. So some of them are easier than others. So in example B, I have a 90-degree angle. The 2 angles across from each other have to be supplementary. So that means X is going to be another 90-degree angle. These 2 angles have to be supplementary. So I'm going to say Y plus 2Y equals 180. Therefore, 3y equals 180. I'm going to divide each side by 3. I'm going to get y equals 60 degrees. So this is going to be 60 degrees, and then the other angle would be 120 degrees. So 90, 90, and then 60 and 120. All right, if you feel like you can do the next few examples, by all means, go right ahead. You can pause it. and do those, and then I'm just going to kind of talk through them really quickly. Hopefully that makes sense to you. All right, so I'm going to go alphabetical order. So this is 100 degrees. These two angles have to add up to 180, so that means 2x has to equal 80. And if I divide by 2, I get 40. Another way I can do that is saying 2x plus 100 equals 180, if you wanted to include that extra step. And then we could say for y plus 87 equals 180. I'm going to subtract 87, and I'm going to do that with my calculator, and I'm going to get 93 degrees. Okay. All right, for the next one, same thing. So for 7, 8, and 9, I'm looking, and I have, and actually an example B, all of these are quadrilaterals inscribed in my circle. The opposite angles are going to be supplementary. So for number 8, I have 2x plus 12 equals 180. If I combine my like terms, 3x plus 12 equals 180. And now it's a two-step, so I'm going to subtract 12, 180 minus 12 is 198. I'm going to divide by 3, and I get 56 for x. All right, and then for y, the math here is going to be nicer. So 4y plus 5y equals 180. So I like this because I'm going to get 9y equals 180. And when I divide by 9, that's going to be a nice 20. And then remember, you can always go back and plug these numbers in to verify that they're working. You're going to get 80 and 100. Of course, 80 plus 100 is 180. If I plug in the 56, I'm going to get 112. And then when I do 56, so this is 112 degrees. And then 56 plus 12 is 68 degrees. And then 112 plus 68 is 180. All right, finally, number 9, if this is a right angle, this is a right angle, so 3x equals 90. Divide each side by 3, and x equals 60. And then finally, 2x minus 3 plus y plus 5 equals 180. And it's really tempting to just say, oh, these are both 90, so don't I set them equal? They are not equal. They are supplementary, so just be careful about that. So 3y plus 2 equals 180, and then I solve, so 3y equals 178, divide by 3. I'm kind of flying through quickly, but I'm hoping you had already done that with a pause video, and I get a decimal. It's okay if you get a decimal. It doesn't mean you did anything wrong, but when I combined my like terms here, I had the 3y plus 2 equals 180, so I'm going to do 180 minus 2 to get the 178, divide by 3, and then just round. So 79.3 is fine. 79.3 repeating is also fine. All right, so when you have one of the angles as a right angle, it's a special case where 180 minus 90 is 90. So right angles that are across from each other in inscribed quadrilaterals, then they're both 90. Otherwise, they're supplementary. The opposite angles are supplementary. So we did 3 rules today that were real important. So the first one is saying that an inscribed angle is half of the arc. We talked about how if you have a diameter of an inscribed triangle, that means this is a semicircle in 180 and half of that is the 90. We said if it's an inscribed quadrilateral, the opposite angles are supplementary. And then the last one, which is not as important, if you have a shared inscribed angle, then the corresponding arcs are congruent. So that is an overview of 10.3. You need to do some practice to kind of get that down for sure, and you're going to be fine. So if I can help you, let me know. But otherwise, you're doing great, and thanks for watching.